So what we are going to see now is how to extend an existing EBS volume which is already mounted on a server, and how to extend the file system on a Linux server also, so that we can start utilizing the additional space. Currently we have an EBS volume which is of 10 GB in size, and it is a standard disk and with the default IOPS configuration. So what I'm going to do is select that volume and click on actions, and you will have this modify volume option. Click on that and you will get this additional window where you can choose whatever parameters that you want, whether you want to move it from a general purpose to provisioned IOPS or throughput optimized or cold storage. So quickly, let us go ahead and change the size alone for now. We can change the performance also, it doesn't matter much. So I'm just going to say 20 GB here, that is I'm going to double the size and then click on modify. So it asks me a friendly advice saying you may need to extend the OS file system on the volume blah blah blah, which is all known, and it gives you instructions also. If somebody is not familiar how to do that in Linux or Windows, you can click on this link and find it out. So let us click on S. Yes, we need to modify it. So the modify request has been succeeded. It will give you the tick mark and green color icon. But if I just close this window, it will usually say, let me refresh it. It will say that it will be optimizing somewhere. Wait a second. Smaller disks, it will probably might happen immediately, but for bigger disks, there will be yeah, there we go. Here it is. You can see here that it is 12% right now. The disk is getting optimized right now from 10 GB to 20 GB, and there is a performance optimization routine happening at the background. So especially if you improve your performance by choosing an IOPS, this might take more time. So Amazon keeps updating it automatically, so you know that when you can start utilizing the higher performance disk or a higher space disk. So let me just go ahead and hit refresh and see how much it has completed. It is still at 12%. It takes some time, but it's not like in hours or days. Of course, that is also depends upon how much the change that you are making. For small disks, it usually happens in minutes, and we should be able to start using the disk right away. Let me just go ahead to the server and do an ls block and see what is the size now. You can see here it is start reflecting the size because it is the performance optimization routine is happening, but the size has already changed and I can see it on my server for 20 GB. So what I'm going to do is I'm going to resize to FS, if I remember correctly, resize to FS and then /dev xvdf. Okay, my file system has been extended now. If I do a df-h for /var/ebs, we should be able to see 20 GB here. So let me just increase my font size so we will see clearly. Okay, so that is how simple it is in the Linux, the Amazon world, to extend your file system, especially if it is small sizes. It is very real time. It took hardly about a couple of minutes to extend it on the GUI in the browser, and then we came back to the server and we executed a couple of commands, and we see the size has been increased, and corresponding performance will also be constantly being optimized on the background by Amazon, and it will take some time to start reflecting. So if you have an application which is needs a lot of performance, and if your application team comes and says, I want an optimized disk, so you can go ahead and do that immediately, but it will take a while for the kind of a performance to be delivered for the application. So you monitor this, and then once it is completed, you can tell the application team your file system has been resized and performance is also the performance optimization routine is also complete, and you can start utilizing it. Or you will find the change in the performance of your application itself once the optimization routine is completed. So that is how simple it is for changing the size of the EBS volume. So snapshots, as we all know in our working sense, it is a point in time backup of the volume or the blocks that has been modified. So you can take n number of snapshots for if your EBS volumes. There is no limitation, or I mean there is a limit, but that is a very high limit. Usually we don't hit it. That doesn't mean that you cannot take backups of your thousands of disks that you have. And in case if you're hitting that limit also, you can go ahead and ask Amazon to increase that. So you can, and these snapshots are incremental in size. So I'll show you how the incremental snapshots work and how the data is stored. And you can always restore all the data by using the latest snapshot of that disk. And if you're deleting some of the older disks, you don't have to worry. All the data will still be there, and still you will be able to restore the full copy of your snapshots. Another interesting thing is all your snapshots, as shown in the diagram here, you have an EC2 server and 3 volumes are there. Once you trigger your snapshot, it gets stored in Amazon S3. It is not exactly in your bucket, it will store. Amazon will store it in the S3 service. So what that means is you are going to get the 11 nines of durability for your snapshots. So technically you don't have to worry about taking multiple copies of your snapshot itself and doing dedupe activity or compress activity or the storage side. You just take one copy and then you're happy about it. And if you need resilience for that as well, you do a cross-region replication and put it in another region, which is also in S3 again. And you don't have to worry much about multiple copies of your snapshot. It's a very powerful feature in terms of backups. Another thing is by using snapshots, you can move your disk from one availability zone to another availability zone, or you can move it across regions also. Let us look at some of these things a little bit in detail now. So when I say snapshots, think of this whole diagram as an AWS region, and then inside that region you have 2 availability zones, A and B, let us call it for reference. And if you have an EBS volume in your availability zone A, what you can do is you can trigger a snapshot, and that snapshot is going to reside in your S3 now, and that is outside your availability zone. If you remember, S3 is not a service which is related to a particular region, it is a global service. So from this snapshot, what you can do is you can move it to another availability zone, or you can move it from here, or you can move it to some other region also. That is also possible. So that is how snapshots come into picture. It is not always just about backup and recovery. It is also to move data from one place to another place, or if you have a client who needs latest image that you have built, or some kind of data transfer, a data set for big data that you need to share with, then you can do some of these things. You take a snapshot of your EBS volume and share it with them. It's very, very simple and quite effective also for moving data across. And when you take snapshots, there are a couple of things that you need to remember. If it is a database that is accessing the EBS volume, you need to flush all the input-output operations and lock the tables. In other words, there should not be any I/O happening on your disk. And if it is a file system that is happening your that is accessing your EBS, then you need to do a FS freeze or a sync so that all the incomplete transactions or pending open files are closed. The reason being that is Amazon takes a memory of a dump of the disk that is being used as an EBS volume. So the amount of time it takes for a snapshot is relatively quick, and also any open files are copied as it is. So in this case, if there is a big transaction that is going on, then there is a big open file. When you're trying to restore it, that open file might not restore properly, and the transaction might be pending or cancelled when you're trying to restore it. So that is why when you're doing snapshots, it is always recommended that you pause or quiz all IO activity, or if that is not possible, go ahead and take it. It will you will still be able to take a successful snapshot, but when you're trying to restore it, you might have some issues with that. So that is an interesting interview question or an exam question. However you see it in real time, always recommend your application team or your business to pause their activity for a brief moment for the snapshots to happen. So always remember that. And there's an interesting tidbit is the entire snapshot of 16 GB is not designed to take more than 1 terabyte. In other words, the amount of time it takes for a snapshot of a bigger disk or smaller disk is all going to be the same. So you don't have to worry about, I have 16 terabyte disk. If I stop, how much time I need to stop? It is going to be relatively very small. You can experiment couple of times with your test environments or dev environments, and then go to production and say it takes 1 minute of downtime for taking the snapshots, and then you can convince your customer to give you the downtime. If that is not possible, go ahead and take it as online backups with the risk of not able to successfully restore it. So that is the interesting bit of snapshots. But what exactly happens when you trigger a snapshot is what we are going to see now. So let us consider this EBS volume. There are three blocks of data is there, A, B, C, and what happens when you trigger a snapshot? So when you trigger a snapshot, Amazon will copy all the blocks A, B, C into a snapshot 1. And let us say there is some amount of activity again happening on the disk. So C has been changed into C dash now. And when you take a snapshot 2 now, and Amazon will copy only the changed data now. So the amount of time it takes for taking a backup is going to be relatively small, because we are going to copy only the changed data. So you will have two snapshots in your snapshot storage. And when let us say there is some amount of other activity still happening on your disk, and say D and E has been created, and somebody goes and creates another snapshot. Let us say snapshot 3 has been created. It will copy only D and E now. And after a period of time, you'll find that you have a lot of snapshots, and you want to do some housekeeping, and you want to delete some snapshots so that your account is clean, so that you go ahead and delete snapshot 1. And you don't have to worry that you're going to lose the blocks A, B, C. What happens is when you trigger the delete action, automatically the changed data gets copied to the nearest next snapshot, or in other words, linked to the next higher snapshot. So always when you restore the latest snapshot 3, it will restore the snapshot 2 and 3, which has all the data totally. So this is what happens in the background when you take a snapshot. It is incremental, and you can still safely go ahead and delete any of your snapshots you want, and Amazon will ensure that you still have all the data in your account. You don't have to worry that this day, if I delete 15th of November, what will happen to my other data? Will I have coherence? Will I be able to restore all the data? You don't have to think about it, since Amazon moves the data appropriately so that you have full copy of all the data. You can go ahead and housekeep your snapshots however you want it. So that is how snapshots work. So what can you do with a snapshot? I spoke about backup and recovery. Let us see how it looks like in a real world scenario. So you have a region, and 3 availability zones are there, A, B, C, and you also have an S3 storage service. And inside availability zone A, you have an EC2 server, which having a EBS volume attached to it, and you start writing some data to it, and there is some free spaces also there. So once what you do is you take a snapshot. So only the written volume, that is not the free space, only the used data. That is very, very important. Some other technologies, when you take a snapshot, it takes the entire disk bit by bit, not only the used data. It just takes the entire disk. If you have 10 GB, it creates a 10 GB snapshot. Here, that is not going to be the case. Only the changed data is going to be copied. And let us say you have written some more data, and you take a snapshot. The snap 2 will have only that much information, and some more changes, and that will be added there. So finally, when you want to restore it or move it to another availability zone, and when you restore it, you get this is what you get: all the 3 together, and the entire EBS volume along with the free space. So simply we have moved the data from A availability zone to C availability zone by using a snapshot mechanism, and using the latest snapshot, all the data is also restored. In case you want to move it to another region, that is also possible. You just create another volume from that snapshot, and that volume can be moved to another region. And you can see the note at the bottom. You can do that across accounts also. As I said, your client want to share some data, you can create a volume and put it into the S3 storage, or taken a permission from their account and create a volume in their account also. That is also possible to move it across accounts. So that is one way. And another way is an AMI. This is nothing but a golden image or an OS image. Quite often people take an image also as a snapshot, or vice versa. From a snapshot you can create an image, and from an image you can create a snapshot. That is also possible. So that also, once a golden image is created by a dev team or a testing team, that needs to be rolled out into production, it follows the same mechanism that we just now spoke about. Once it is in your account in one availability zone or one region, you can move it across. Say in this case in Oregon, you have an S3 bucket and you have Linux and Windows and you have an EC2 root, and you create a custom, you just add some more data, some more binaries, and then you customized it now, and you created a machine image and you put it back into S3 now. So from here, what you can do is you can move it to another region within Oregon. It's another availability zone within Oregon itself. Or what you can do is you can move it to another region also, and you get your custom image as well as the base images also. So there is another common use case people use for snapshots, creating golden images and then pushing it across different regions. And what it does is it's something like a separation of duties. The people who create the golden images are not going to deploy it into production. So that way they cannot, they cannot use the vulnerabilities that might be there, or they cannot create vulnerabilities and go to production also. And another thing is, as shown here, Amazon itself shares a lot of data sets in EBS volumes. People who want to use big data analytics and they're looking for data, what they can do is they can go to Amazon public data sets. The URL is shown here, and a lot of EBS, a lot of data is available. You can create a snapshot into your account and start using that data itself. In other words, people have created data sets and made those EBS volumes shareable so that you can share it with the other world and what kind of data you have. Some of the example is genomic, sensor, global weather, and transportation related data. There is an Amazon IMDb related data is also there. Movies database is also there. You can try it out when you need. So that is what it is. Okay, and tracking and the cost. I have always mentioned to you guys, this is to impress upon the topic that always tag your resources in Amazon so that you can track the cost and always build the appropriate department for those costs. And since it is a key value pair and there is a very marginal cost associated with it, you can go ahead and have multiple tags possible. Say one tag as you shown here, it can be environment and can be say dev. Another tag can be department and say production, or when you say HR, when you say department. Another tag can be saying this is for application version 1, something like that, or this is a POC environment, things like that. So environment wise and department wise and user group wise, or you can say SSD disks, anything you want to have or meaningful way, you can use tagging, because a lot of times people write scripts and those scripts will look at what is the disk, and if it is a production disk, it will take a snapshot. If it is a dev environment or a test environment, it will not take a snapshot. And that mechanism will be driven by the tags that has been associated with those disks. So it is quite powerful in terms of maintaining and controlling the costs. So almost always tag your resources. This we will see later. This is a snapshot of a screen where you can explore the cost of your disks based on usage. Say for example, if you have created that tags, then you can come and explore it in your billing dashboard. If you have not created those tags, it won't appear. So that is the reason I say keep adding those tags, then you can go ahead and start using that cost explorer window and then see the usage. So quickly what we'll do is we'll go ahead and create a snapshot, and then we will try to restore it into another server. So we see here there is my volume. This is my EBS demo in volume, which is of 20 GB in size, and all I need to do is for creating a snapshots, make sure that I'm selected the disk that you want to take a snapshot of. And if you also remember, we have written one single file there. So when we mount it to the next server, we should be able to find it. Okay, yeah, under actions, you have create snapshot. So a demo, I'm going to say EBS snapshot demo. I'm just going to copy that and put it into the description also. And if you remember, when we created the disk last time, it was encrypted, so it is still showing as, when you take a snapshot of an encrypted EBS volume, it will always be encrypted. So you cannot restore, in other words, I cannot take an encrypted disk and try to restore it, create a volume which is not encrypted. So if you want to share this with your client, you need to unencrypt it and share it, because the keys for this disk is in my account, and they will not be able to access the data inside my volumes. So if you want to share it, you need to restore the data or copy the data into an unencrypted volume, and then make a snapshot of that and then share it. So little long process, but that is what encryption is all about, making sure that nobody else have access to the data unless they have access to your keys. So the snapshot process has been triggered, and this is my ID for my snapshot. Let me close this window and hit refresh here. Okay. The reason I did a refresh here is, if you can see my screen, the state or in use, the optimization is completed and it is at 100%. And here also it was an yellow color blob. Now it is being completed and optimization is done. So now we have triggered a snapshot. We'll go to the left hand side and see a snapshots icon. Click on that. There should be two now at least. One is, okay, the OS disk will get later. Okay, so this is my snapshots for my 20 GB disk. We just now triggered, and good, it has been completed. I was expecting it to be in progress. Anyway, it is completed now. So what we can do is, we are going to create a volume out of this and mount it to another server. So for creating a volume, select the snapshot, click on actions, click on create volume, and it picks up the default actions already. Let us see what is our current availability zone for my server. Let me go to instances. Under instances, my availability zone is 1A, as you can see here. So I'm going to move this snapshot into 1B availability zone or into volume. So that is done. Click on create volume. Let me add a tag as well. ACB. Yeah. Okay. Click on create volume. So now my volume is ready. I just need a server to access it. So what I'm going to do is click on instances, launch instance, or I'm going to show you another shortcut. Let us see whether it is going to work. So I have one running instance already. I'm going to need a similar configuration, just that I need to change this availability zone to 1B. So what I can do is select this, go to actions, and click on launch more like this. So what Amazon automatically does is, it picks up all the configurations and comes to the final page here. So I just need to change my availability zone details, which is under instance details here. You can see here under this VPC, this subnet. So I'm going to edit this and change it to availability zone 1B, and go to review and launch. Rest of all the details I don't want to change. And I want to have a public IP so I can connect to it also. So let me just ensure, okay, public IP is enabled. Review and launch. Click on launch. Launch. So you see here I have two servers now. One is in availability zone 1A and 1B. And another neat trick is, I can just go ahead and edit this little bit, so we know that exactly which server we are dealing with. This won't reflect on the server, but on the console I will be knowing exactly which one I am dealing with. So this is 1A. So still my IP is coming up. Come on. Yeah, my IP is up. So let me go ahead and connect to this server now. And while the server is booting, what I'm going to do is, I'm going to attach my volume now to the second server. So this is, see, it is easy to have a nice name so that we know exactly what we are looking at. So EBS demo in ACB, and you can see here it is also an available state. That means that it is not in use. So what I'm going to do is I'm going to attach this to my new server. So attach volume, click here, and you can see here EBS demo server 1B. It is easy to identify our servers if you have nice tagging in place. So click on attach. So while this is getting attached, and go back to my console, sudo su ls. Okay, before ls I'm going to do df-h. So if I do a df-h, as you can see on my screen, there is only one disk, and if I do a ls block, I should be able to see the additional disk of 20 GB, and it is already formatted and it should be ready. So we don't have to format it, we just need to mount it. So mkdir-p/var EBS, let us call it 1B. So I'm going to do a mount of this disk. So if we do ls-l and go ahead and check the file, my data is available, in other words, in another availability zone. So technically what we have done is we have moved data from one availability zone to another availability zone in about 5 to 10 minutes, assuming even if there's a 20 GB of data is there, without doing an rsync or a tar or a WinSCP, we have moved about 20 GB of data from one availability zone to another availability zone by doing a snapshot, creating a volume, another server, and we are ready to access it. And remember, this disk is still encrypted. So I am able to access an encrypted disk since it is all in my account. The keys automatically come into picture and the decryption happens in real time. So there are 4 or 5 important best practices that you need to keep in mind when we are talking about EBS best practices. I'm going to quickly run through some of them so you can have that in your back of your mind when you're designing for your clients. So when we are designing, the 4 important things is you need to look at the availability, which are all the availability zones you need, how much availability your client needs, and what is your durability also requirement for your client, whether you need a magnetic disk or you need an SSD disk or you want a provisioned IOPS disk. So that defines your performance of your EBS volumes appropriately. You can choose whether it is 200 IOPS, 300 is the 100 is the minimum, yeah, and you can go all the way to 20,000 for per disk volumes, and whether you need encryption or not. And remember, when you're doing encryption, when you're sharing it, you need to ensure it is not encrypted by taking a copy of the data to an unencrypted disk. Quite often that is a trick question. Whoever you're dealing with might ask you that question. So if I go ahead in deep, when you're talking about the multi-AZ, as I said in the beginning, always use multi-AZ for high availability. So whenever your client or somebody says, I want high availability, the first thing that should come to your mind in the Amazon world is, I need to use multiple availability zones. Straightforward is like a 1:1 mapping. Just think of it always as multi-AZ equal to high availability equal to multi-AZ. So in this case, there are 2 servers and each of them having an EBS volume serving the same data. Let us say, for example, very simple application here, and it is pushing the data out to the internet. And for some reason, one of the availability zones goes offline. If you have automatic failover configured, or if you want to do it manually also, you can take a snapshot and push it to the other availability zone, and you can start serving your traffic to your internet or your downstream systems if you have such a mechanism possible. Usually what happens is there will be a load balancer in front of it, and when the failure has happened, the load balancer will shift the traffic from one availability zone to other availability zone. For simplicity, I have not shown it here, but usually it will be there. So 2 availability zones, even if one goes offline, you will still have one availability zone. And if you want a really disaster recovery solution, then you duplicate data across the regions and use your DNS to shift the traffic from one region to another region. So that is also possible. And remember that when you're talking about availability zones, that we are talking about multiple data centers inside one availability zone. So the chances of one availability zone going offline completely is very, very less. I'm not going to say it won't happen. It has happened in the past, but the amount of time it has been down has been very, very less compared to the size of the outage that happens when it goes offline. They are usually quick and they bring it back pretty fast. So that is one thing, and another thing is there are certain type of instances or server types that is available in Amazon, which allows you to bring them back automatically when something goes wrong. Say for example, you have created an EBS volume and chosen an instance type of a C3 or C4 or any of the ones that is mentioned here, and you can have CloudWatch, that is a monitoring tool, and set up monitoring for that instance. For some reason, if there is a failure for that server, that is at the hardware level, CPU or memory, what it can do is it can recover the instance automatically. It will reboot the instance automatically and apply the same details that you can see on the right hand side. The instance will retain the instance ID, the instance metadata, private IP address, elastic IP address, and all the EBS volumes. So it is just a checkbox in the monitoring. There are two metrics that is mentioned here. So these are the metrics. So once you configure it, and this will work only on these instances, not on T2 Micro or any of the free instances. So don't worry that if it is not showing up for you when you're going to CloudWatch. If you have started a server on C3, C4, and if you set up this CloudWatch, automatically it will reboot, or automatically it will try to recover your server whenever there is a failure that has been identified. So this is another way people design a recovery or resilience systems in Amazon world by using auto recovery option. So another one, encryption, we already saw. In encryption, we already saw it's just a checkbox that you need to do in Amazon for encryption. Once again, the encryption is provided to you at a very marginal cost. It says no extra cost. The reason being that is if you're using Amazon keys, there are no extra cost for you. If you're bringing your own keys, then every time a read write happens, Amazon has to retrieve the key, and there is a slight marginal cost, I would say, to retrieve those keys and then encrypt or decrypt with those keys. So in other words, you can encrypt or decrypt with your own keys, or you can use it Amazon itself. When you use Amazon keys, they automatically rotate the keys on the background. So that way you can be sure that your keys are not always constant, and automatically Amazon changes the keys over a periodic time, which is not exactly published, but they rotate the keys quite often, and all the keys that they are using to encrypt is again encrypted using a master key. So that way your data is really secure, or that is how Amazon presents the security in EBS volumes. So there are two types of keys. That is what you need to remember: the default key or your custom key. So that is it. And for encryption, it's no longer a complicated, tough topic in terms of disk administration anymore in cloud. You just put a checkbox and say encrypted, and everything is taken care by the cloud provider itself. And this is what I was speaking about. The key itself, the data key itself, is never stored in terms of plain text in the server. Always there is encryption for the key itself, and it is stored. So that is another level of security. So moving forward, a snapshot or a Twitter size feedback or a Twitter size bytes for best practices. Your block size, remember I was speaking about this. Your block size determines whether your application is IOPS bound or throughput bound. So if your client says that I want to write 64 KB of data each time or 256 KB of data each time, so you will know that whether you need throughput more or you want to IOPS more. So talk to your application team and say what the amount of data that they need. Next thing is always use SSD disk for boot volume. It is quite obvious, I don't even have to explain it. If you want a faster boot for your server, you want to have more IO happening at the same time. So instead of saying even IO, I would say more input because you're doing a lot of read operations at that time for booting, and boot volumes are best in SSD. And when you are really thinking about performance, the best performance is always SSD, and it's also costly. But if you are more worried about performance, blindly choose SSD based disks. That gives you the best performance Amazon offers. And for SSD, the performance or the IO size is 256 KB. So that is how your IOPS is calculated for you. So one block of IO is 256 KB in SSD disks. And for read and write, SSD disks gives you the same level of performance. So whether it is a read intensive application or a write intensive application, when you choose SSD, you get the same consistent performance throughout. And if consistency is of the key, your server also has to be optimized for it. Remember, so far we are using T2 micro. There are certain instances like, for example, R series, RAM optimized or read write optimized. They take advantages of your EBS disks, and network level optimization is already done. So in other words, choose instances which are EBS optimized for consistent EBS performance. So both of them has to be at the same sync to get the best performance of your CPU and as well as the disks as well. So we will look at EBS optimized disk or different types of instances when you are looking at the instance EC2 classes in depth. For now, just remember that both of them have to be at the best performance configuration to get the real high-end output. This is at the IOPS level. If you're not able to follow it, I would say ignore it. It is not mostly system admins or cloud admins will require it. This is for saying typically your IOPS latency, the optimal queue depth, the amount of queue that you want to maintain has to be 4 or 8. If you're having a very long queue, then you need to look at your application level optimization itself. So ideally, when you say 256 KB, we are talking about 1 MB of write operations per second. If you're having more than that, you're not going to really get good performance from your systems. So this is all fine tuning or performance tuning of your application and your environment itself. If you're working at in-depth level, you can research this more and you will get more data on that. And finally, selecting the right EC2 instance or selecting the right EC2 instance along with your EBS disks gives you the best performance. Just a gentle recommendation, it's like your doctor saying take rest, it always works. So select the best instance in the cloud world, always works. As a summary, select your write volume first, then select your write instance, take snapshots, tag your snapshots, and use encryption when you need it. Just because it is easy to put a checkbox, don't use it. It is not going to add any value to it. And if you're going to share it or going to have multiple people accessing it, it is going to become much of a hassle rather than a benefit. So choose encryption wisely.